2019 Differential Calculus, question 10a. A particle P moves along a straight line. The speed of P at time t is v, where v is equal to at squared plus bt plus c. A, b, and c are constants. The initial speed of the particle is 15 meters per second. That's the initial speed times 0. After 2.5 seconds, the particle reaches its minimum. So all these keywords within this question, speed of also 2.5 meters per second. Find the value of a, b, and c. Okay, well, we'll do that first. The value of a, b, and c. Okay, v is equal to at squared plus bt plus c. And we're told the initial speed is 15. So we can plug in t is equal to 0. We're going to get c is equal to 15 here. So 15 is equal to 0 plus 0 because t is 0 plus c. So initially we can get c straight away. C is 15. So this minimum speed part, this is going to be, if we have speed, we know this formula from before, v is equal to u plus at. So what if we differentiate v, speed, with respect to time? U is a constant, it'll go to 0. We're just going to get acceleration. And we know that at minimum we can let it equal 0. So if we do dv dt, so dv dt is equal to 2a times t plus b. And after, when is it minimum? 2.5, when t is equal to 2.5. 2 times a times 2.5 plus b will be equal to 0 because it's a minimum. So we get 5a plus b is equal to 0. So that's my first equation in a and b. And we can also use this time and speed to plug into the full formula again. So velocity to speed of 2.5 is when the time is also 2.5. So that's going to be 2.5 to be squared times a plus 2.5 times b. We have c. So we're going to get 2.5, 25 25s are 625, so 6.25a plus 2.5b plus 15. They all have a factor of 2.5. So if we divide them all by 2, what do I need to? I don't probably need to, I don't at this point. 6.25a plus 2.5b is equal to minus 12.5. If I bring the 15 across, I have this equation here. I can multiply by 2.5 or minus 2.5 to get rid of the b. So minus 5 by 2.5 is 12.5 minus 2.5b is equal to 0. So I'm going to get minus 6.25, and you can see it's going to be equal to minus 12.5, so we just let them both be pluses. So that would have my a being equal to 2. And now just sub back in, 5 times 2 plus b is equal to 0. So b is equal to minus 10. So v is equal to 2t squared minus 10b plus 15. Part 2, we're told asked to find the acceleration of p when t is equal to 4. Well, we saw already what acceleration is, dv dt, velocity over time. So dv dt, now that we have our constants, is equal to 4t minus 10. So when t is equal to 4, we just plug this in, we're going to get 4 by 4 minus 10, which is 16 minus 10, which is 6 meters per second squared, or ms to the minus 2. So that's a. And then in part 3, the distance traveled by p in the third second of motion. Part 3, the distance traveled by p in the third second of motion. Okay, well, we have v. Distance is our displacement s, so ds dt. If we want to get s, what distance is, imagine this is 1 ds dt. If we get the integral of 1, we're going to get s. So we have 2t squared minus 10b plus 15. Sorry, 10t, I wrote 10b up here, look, 10t. 10 t's and b's, 10t plus 15. So if we get the integral of this guy, respect to t, we will get back to my s, which is here. And it's between, we're in the third second of motion, so that's between the second and third second, so between 3 and 2. So if we integrate this, we're going to get 2t cubed over 3 minus 10t squared over 2 plus 15t, and we don't need our c here because they cancel out. So just tidy it up between 3 and 2. And you can see this 10t squared. You could write 5t squared at the start if you wanted. Just, I find if you try to go too quick, particularly me, I make mistakes. So we're plugging in our 3 and our 2, and this is going to give me the distance in the third second of motion. So I'm going to have 2 by 3 to be cubed over 3 minus 5 by 3 squared plus 15 by 3 minus, when you know your integration rules, 2 by 2 cubed over 3 minus 5 by 2 squared plus 15 by 2. And at this point it's just really calculator use. You could try and simplify it down if you want to have a little bit of fun without your calculator, but you're in an exam pressure situation. Type this into your calculator, get both values, and then simplify them, because if this is a minus, it's going to become a plus, and sometimes you may just miss the sign on your calculator. So typing both of these into your calculator, you're going to get 18 minus 15 and a third, which is 2 2/3, and this was in meters.